Are there any predictions for the deflection of light by the black holes due to delta Q?
Coincides exactly with Schwarzschild solution in Schwarzschild coordinates. So,
not large distances. They go through the black hole altogether. So there is influence for the center of the black hole.
I do not know. I didn't. This paper was written less than 1 year ago, so I didn't calculate anything.
Visible, observable consequences of this conclusion to quantum black holes?
There are very many questions. For example, if two-point particles cannot come close one to the other, because gravity becomes repulsive at small distances. There is now there is a problem how a black hole can be formed, because particles cannot be very close one to the other.
Attempting to observe quantum black holes on the accelerator. So should we make any corrections to predicted properties due to this? And if yes, then which corrections?
I do not believe. In fact, at large distances, for example, in our galaxy, this solution is exactly
That's why
the
I'm
Schwarzschild.
asking about accelerator. If you get close, it's exactly the point where this effect may be observed.
I do not know. So at large distances, there is no difference.
Okay, hello.
See, you have raised a very important problem, very important problem. The so-called Schwarzschild solution is supposed to be the exact solution. It is indeed an exact solution for a neutral point mass. And it is the basis of black holes, the concept of black holes, and it is the basis of the popular form of relativistic astrophysics. And your point is that, after all, you are starting with the point mass, where the energy momentum tensor should have a Dirac delta function. And then, but it does not satisfy. So you have tried to solve this problem in a particular way, and I very much appreciate your effort. But unfortunately, what you are showing is that by coordinate transformation, the problem is a physical problem, and coordinate transformation cannot solve this problem. Here also, as you can see, the singularity is very much there, and your small r is m by 2. The same event horizon there, actually you have not solved the problem. It has been shrouded by some coordinate transformation, and I addressed this problem. What I showed in my Journal of Mathematical Physics paper by American Institute of Mathematics in 2009, that if you take the Schwarzschild solution and take another coordinate, say Eddington-Finkelstein coordinate, and study the properties of the coordinate transformation, then the limit of the point mass, the Schwarzschild integration constant becomes 0. Physically, what means is this, that if you take Schwarzschild solution, what you was telling, the deflection around the sun orbits fine. Then you have Schwarzschild solution, integration constant is finite, central object has a finite mass. But suppose now it contracts. It contracts to become a point mass. In reality, it would radiate, and what my solution, this Journal of Mathematical Physics tells that, when it would reach a point particle, this becomes gravitational mass becomes 0. And then your problem is solved. So then there is no black hole. Physically, that means so-called black holes with finite m must be something else. Thank you.
Should I answer? I don't know. I proved that this is the solution of a coupled system of equations with delta functions, nothing else. This is exact solution. Schwarzschild solution in Eddington-Finkelstein coordinates or Kruskal-Szekeres coordinates does exist. So there are two different solutions, and the Schwarzschild solution in Kruskal-Szekeres coordinates does describe white and black hole. But it doesn't describe point particle. Point particle is described by this solution, and this is the result.
It's known the solution for the massless particle, IK group sexual, that we heard. And they obtain solution just by boosting the Schwarzschild solution. Yes. Is it possible to do something like that in your framework?
No.
the coefficient before dt squared is n squared, right?
Yes.
And the original n, is it the expression under this square, or is it model of this?
There is a subtle point, of course. My solution n, the left function changes sign when you cross the critical sphere or horizon. So it is positive outside, it is negative inside. If you choose modulus sign, then n will be not continuous function and equation will not be satisfied.
Change its direction. Am I right?
You mean observed time? I don't.
External.
This is physical
Time for
interpretation.
external.
This is physical interpretation.